show you the ratios here. I'm not going to write too much here. It's just a ratio. And this is also a ratio. And you write it like this. The sine of theta is just a given angle. It's just a given angle equals, so this ratio comes from the opposite leg over the hypotenuse. So instead of opposite over adjacent, you're doing opposite over hypotenuse. And we talked about theta last time. Am I confusing you with theta?
No.
It's just a given angle. It could be 23, it could be 42, it could be something. Okay? All right. Cosine is another ratio. The cosine of theta, the given angle, is the adjacent leg over the hypotenuse. And I'm going to show you a little tricky way to help you remember all these. So let's just write tangent here too for the heck of it. Tangent of theta is equal to what? Opposite over adjacent, right? So I'm going to show you a little trick that's ancient of how to remember these, because you have to remember them. So look at the first letter. S-O-H. See it? Sine equals opposite over hypotenuse. So if you remember this, S-O-H, just stay with me. And then look at this, C-A-H, Ka, and then T-O-A, T-O-A. Say it with me, So-Ka-Toa. It's kind of got a ring to it. SOHCAHTOA. SOHCAHTOA. It will help you remember these forever. I like to think of it as an Indian chief. It kind of sounds like an Indian chief's name. I don't mean to be weird about that, but SOHCAHTOA. SOHCAHTOA. So, hey, what does the S stand for? Sine equals what?
Opposite.
Ka. Cosine equals
Adjacent over hypotenuse.
what? Tangent equals. You got it. Okay? All right. Angle of elevation. So, elevation. I like to look at this picture. It's a really good picture here. Just think of looking up. Looking up. Think of it like that. So look at this guy right here. He's standing there, and he, I think it's a he, is looking up at this person up here on the cliff. That is the angle of elevation. When you're looking up at something, okay, compared to this horizontal line right here, it's the angle of elevation. Well, let's say she, right here, is looking down at that person. That forms an angle of depression to this horizontal line. When you're looking down at something, your line of sight is forming an angle of depression compared to if you were looking straight ahead. Does that make sense?
Yes.
Okay. Looking down. Elevation, you can just think of elevate like looking up, right? Depression is like something pushing you down. Make sense? Okay. And you're going to work with that today too. All right, turn it over. Let's write the chief's name up on top. What is it? SOHCAHTOA. Okay. Shh. You're going to have to decide which one you need to use for some of these problems. So you're going to have to decide what you need. And it's a rope staked 20 feet from the base of a building, goes to the roof, and forms an angle of 58 degrees with the ground. To the nearest tenth of a foot, how long is the rope? So I need this. So from this angle right here, I'm working with the what and the what? The hypotenuse? Okay, so hypotenuse and adjacent, so I'm going to use what? Ka. Okay, so the cosine is equal to adjacent over hypotenuse. That's ka. So I'm going to say cosine of 58 degrees, which is the angle they gave me, equals the adjacent, which is 20, over x. Now, you can place this over 1. You just cross multiply. 20 equals the cosine of 58 times x. This is just a number. Don't ever split it apart. You can't. It's just a number. So basically what you're doing is you're doing x equals 20 divided by the cosine of 58. Now, go to your calculator and let's see if we all get the same number. Make sure it's set to degree mode. Again, if you have an Aspire, I don't know how to do that. Grab one of the ones in the front, Bella, because with the little sticky notes, because those are 84s. If you're on an 84, just push the mode button right here. Mode. Emma, you looking? I don't know how to do Inspire. That's what I said. I've got 84s over here. I've got 84s in the front here. If you want to just use an 84. The ones with the little sticky notes are 84s. Or I've got them over here. $37.7 is what I got. Yes?
The price is right.
That's right. Okay, if I were taking a test or quiz right now, what could you double check to just sort of see if you're doing it correctly?
You could do that A squared plus B squared.
You could, except you don't know this side. But what you, on that note, you should check that this number is bigger than what? 20, because it's the hypotenuse. That's one small check you can do. If you get a smaller number, you got a problem. So the hypotenuse is the biggest. Yes, Ben? Well, you can't do tangent because you don't know this measure. Oh, well, if you did this, then you'd still have to do this because you're looking for the length of the rope. Make sense? Okay, and it'd just be an extra step. All right, find the sine and cosine of angles R and S. So let's start with angle R. Start with angle R. So I'm going to start with the sine of R. I don't know the angle measure, do I? But I have both of the side lengths, so I can find the ratio. So if I'm up here, the sine of R is equal to SO, which is what? Opposite over, yes, so opposite over hypotenuse. So from R, the opposite is 8, and the hypotenuse is 10. So the sine of R is 8 over 10. You don't need a calculator for that. What's 8 divided by 10? 0.8. 8 tenths. 8 tenths. And you're done. Cosine of R. So from this angle, what is cosine again? So ka is adjacent over hypotenuse. So it's 6 over 10. Because I'm going from R here. 6 over 10, which is what? 0.6, 6 tenths. Okay, I want you to do angle S. Do the sine of S and the cosine of S. Joe's to find the missing variable. So we can do different things. We do know this angle. We could figure out that angle if we had to, but we don't need to. We can just go with 41 here. What do you want to do first? So or ka? Do what you want first. I don't care. We'll get the same answer. I'm going to start with so because it goes in order. So ka. So sine of 41, and the O means opposite, which is 17 over D. Opposite over hypotenuse. Now, they like to twist these triangles around, so make sure you're looking at the hypotenuse, right? Make sure you got that orientation correct. Okay? Then the cosine of 41, here's 41, is equal to the adjacent, which is C, over the hypotenuse. Can I do that yet? No, because I don't know the hypotenuse, but I'm about to find out using this. So I'm going to find the hypotenuse first. Sine of 41 times D equals 17. Cross multiply. So then you just do D equals 17 divided by the sine of 41. What'd you get? Yeah, I got 25.76 or so. I just rounded to the hundredths. Okay. Now I can find the cosine of 41. Cosine of 41 is equal to the adjacent over the hypotenuse. So C over 25.76. And here you're just going to cross multiply. C is equal to the cosine of 41 times 25.76. I didn't even finish that. What'd you get? Times 25.76. Yeah, 19.44 is what I got. Cool?
I got 25.9.
Did you push cosine 41, enter, and then times 25.76, or did you use parentheses? Makes a difference. You either have to close the parenthesis or you have to push enter and then multiply. Did it work?
Yeah.
Okay. All right, 2 more problems, you guys. Here we go. A pilot is looking at an airport from her plane. Okay? Oh, I'm such an artist. I need to do this. So here we go. Not really. It's pretty ugly. Here's my plane. Okay? An artist is looking at the airport. So here's the airport. From her plane, the angle of depression, that's right here, because she's looking down, is 29 degrees. If the plane is at an altitude of 10,000 feet, approximately how far does the plane have to go to get to the airport? So we're going to look at this distance right here. This is how far the plane has to go, right? Not this distance. The plane has to go this distance. So this is my x. I'm going to assume that it forms a right triangle. That's a bit of an assumption there, but okay. So when you have a problem like this, you have to decide which ratio to use. If you're looking at this angle, you have the what? What side is this? Adjacent and hypotenuse. So which one is adjacent and hypotenuse? Ka, which is cosine. Cosine of 29 equals the adjacent. A lot of people get these mixed up. The adjacent leg is 10,000 over my unknown. This is 1, so you just cross multiply. This is a single number here, so you're going to divide by all of that. And then you just can go to your calculator and do this calculation right here. What'd you get?
11,430
Correct. Feet. Again, you have to watch your parentheses. If you're jumping into this single step here, I like to use more parentheses maybe than I need. You do it like this, or perhaps it works like this, divided by cosine 29. Close that parenthesis. Yeah. Okay? Let's do this last problem just because it involves a squirrel and a dog. Okay? A dog is looking at a squirrel at the top of a tree. All right, so we have to draw a picture. I'm not even going to try and draw a squirrel. I'm going to write the word squirrel. And I'm going to write the word dog. Dog and squirrel. The dog is looking at the squirrel. I'm a little bit off here, but that's okay. And the angle of elevation is 64 degrees from the dog looking up at the squirrel. How high is the squirrel? And how far is the dog from the base of the tree? Oh, we have two unknowns we need here. We need X and we need Y. I'm missing something here. The distance between the two animals is 55 feet, so this is 55 here. Why don't you try that on your own, and we'll come back and meet. So you have to do for one, and then you got to solve for the other. Okay, questions on this at all? Not too bad, right? It's a matter of setting it up right and using your calculator properly or the back of the book.